Okay, I will record
This meeting is
session,
being recorded.
and we'll post the workshop on our YouTube afterwards. Now I will hand over the time to our speaker today, Vince. Okay, Vince, you can go.
Yeah, thanks, Zach, for facilitating all this. I'll take over the screen. So, all right, maybe you can give me a thumbs up if you guys can see my screen. All right, okay, thanks, Aaron. Yeah, okay, so let me begin. And I've actually given a workshop last week on regenerative finance, and some of you may have already seen me speak and also already known me, but let me introduce myself again once more. So I'm Vincent, and I am part of the team from Metacamp. And basically what Metacamp does is we are actually a education provider that teaches people and also nurtures people to become talent in the Web3 space. So we have things like workshops, boot camps, and also as well as hackathons that we organize and make sure and get people up to speed on blockchain related topics. And for myself, I used to study analytics back in university, and when I got out of university, I was a data scientist, and I slowly transitioned into a software engineer, and then subsequently aped into a couple of NFTs. Never looked back, became a blockchain developer onwards, and now here I am, trying to get everyone into the Web3 ecosystem and impart some skills and knowledge of mine. Yeah, so let me begin. Today we'll be talking about on-chain analytics. We'll be understanding how data is stored on the chain, and as well as how we can actually read the data on chain and how to make sense of the data on chain. All right, so today it will be a very data heavy lesson. All right, and we'll be zooming into a very interesting use case on the blockchain for data analysis. Okay, so for this session, I hope that this would be as interactive as possible. So please feel free to stop me whenever you want. If you have any questions, any doubts, just ask away. Could be you can unmute yourself, you can ask, or you could just type in the chat and ask. I'm fine either ways. All right, so let's begin. So if you want to follow today's slides, please access the slides here, and I strongly encourage you to access the slides via this link as well, because we will be downloading a Jupyter notebook, right? Which, if you're not familiar, Jupyter notebook is basically like an IDE but for Python, and it allows you to execute code by blocks, which is very, very convenient. So yeah, access these slides, and thereafter, when we reach the last slide, you would be required to download a notebook, and you can follow along if you like to. Okay, I'm just gonna put this link on our Zoom chat so that if you missed it out, you can still access it. All right. Okay, so just to recap what blockchain is and how blockchain technology works. I believe I've already mentioned this last week, but I'll repeat this again. So for blockchain, every request is a transaction. So let's say if you are if you are familiar with Web2 technologies, right? For example, when you access the website, you're actually doing a GET request. When you are, creating a user on a platform or modifying a user on a platform, you're most likely doing a POST request. So instead of your HTTP, your normal HTTP REST API request, right? On a blockchain, we call them a transaction. So a transaction occurs whenever you try to modify data on a blockchain. So if you are reading data from blockchain, you don't need a transaction for that. However, let's say if I want to send money from my wallet to another person's wallet, okay, that would have to be a transaction, because we have to record that down on the blockchain for any changes in terms of data. And when we talk about data, it means the data I own, which is the number of, perhaps USDC I own in my wallet, and the number of USDC the other person own in his or her wallet. Those are data. All right, so a transaction is requested, the transaction is broadcasted to a peer-to-peer network, and this peer-to-peer network would be your computers or your servers, and we call them nodes in blockchain term, spread out across the world. So this network of nodes uses certain algorithms. So every blockchain protocol would have different algorithms, all right, based on their different needs, and they would then validate the transaction and user status. Right. So once a verified transaction then can involve cryptocurrency, contracts, records, or other information. So once it is confirmed, the transaction is combined with other transactions, right? And once verified, they create a new block of data. So you can imagine that this block of data, it contains many transactions. All right. And blockchain basically is a chain of blocks. So what is inside the blocks? It's just many transactions. All right, so the new block is added on top of the existing blockchain, and when you whip out your phone, you take a look at your transaction, perhaps on the Explorer, you will see that, okay, your transaction has been finalized or has been confirmed. All right, so this is how blockchain technology works. And you can see that every time we make changes on the blockchain, when we try to do some things with regards to data on the blockchain, there are always traces, whereby traces are in terms of transactions. And via these transactions and via the data on blockchain, there are actually a lot of use cases that we can leverage the data on blockchain to. So the first use case would be transaction monitoring. So for example, we can identify patterns, trends, and potential risk related to financial transaction. And this can be very useful in detecting fraud, money laundering, and other financial crimes. So one very interesting use case, if we were to talk about more on the Web3 side of things, is there's this thing called wash trading, which is very common in blockchain. So for example, when wash trading occurs when someone is trying to sort of fake the volume of a particular asset. So for example, right, let's say if today I own an NFT and I want to make my NFT's value to be seemingly more valuable. So what I will do is I will create two wallets, and then what will happen is I have this main wallet. I would fund my second wallet with my main wallet. Maybe I fund it like maybe 20,000 USD, right? And then with my main wallet, I would list my NFT on the marketplace, and I would use my second wallet, to buy up the NFT with 20,000, which is I'm actually essentially selling it back to myself. But people wouldn't know, right? Unless they use like certain sophisticated methods to identify wash trading, people wouldn't know. So all this data on chain, right? Like all the transaction flows, all the money flows, and things like that, it's all on chain, and hence we are actually able to leverage all this data and produce these insights, such as identifying wash trading. So this is actually one of the examples of transaction monitoring, and this is so useful because data on blockchain is transparent. All right, and second, it's market analysis. It is able to provide insights into market trends, such as demand for certain tokens or behavior of traders. So this information can be used to inform investment decisions or identify new business opportunities. So yeah, like what I mentioned, blockchain being transparent and all the transactions can be seen by everyone else. We are able to plot out visualizations, such as what's the demand for particular tokens. So for example, today there's a new launch of a token called shadow tokens, and we are able to see, okay, who are the buyers of the shadow token. So which wallet addresses are buying up shadow tokens, and these wallet addresses, right, what are their common behavior? Are they like NFT users? Or are they like people who, frequent NFT marketplaces? Or are they people who are, very deep in DeFi, doing a lot of staking, doing a lot of yield farming, things like that? So we are able to, identify trends from a group of users, and then, using whatever information we are able to gather from this analysis, we are then able to target people even better. Like, for example, if I am someone who wants to create a new token that's very similar to Shadows, right? I would then, target this group of people. Let's say if there are people who frequent NFT marketplaces, then I'll for my marketing message, I will target this group of people. So yeah, that's one way you can use market analysis. And lastly, it's for supply chain management. So data analysis can be used to track movement of goods, materials through the supply chain, providing greater transparency and accountability. So these can help reduce fraud, counterfeiting, and other supply chain risk. So this one is pretty straightforward. Whenever, for example, if you have a physical good, and that physical good comes with an RFID chip or something that can be tagged to a certain identifier, we are then able to, based on the physical goods location, we are then able to place this identifier to a correct sort of state on the blockchain. And other people, since blockchain is transparent, other people are able to access the state of each identifier and be able to know, like, for example, oh, this particular good is at this area, and it is impossible for it to be somewhere else. If not, it is a fake good that I'm seeing. So things like that. So the types of data on the blockchain, there are many different types of data on the blockchain actually, but including like things like pictures and your animated files and things like that. But I've identified the 4 more common ones. So the first one is, of course, transactions. Transactions are your building blocks. Okay, so the transactions. So for the link to Jupyter Notebook, just for your info, since I think someone pointed out, it is not the first. The first link is to the slides, all right, for you to follow. But the Jupyter Notebook link is towards the end of the slides. Okay, so for transactions are the building blocks of a blockchain, and this transaction will include information such as the sender, the recipient, the amount sent, and the transaction fee paid. So depending on the blockchain protocol, different transactions may contain different information depending on the protocol. So we'll dive into Solana's transaction later on. All right. And secondly, it's the smart contract code. So you can think of smart contract code as logic that you sort of created, and you can think of them there's something similar to your backend server, right? Where, for example, in your today's backend server, let's say you have a very traditional RESTful API where you have get, and then you can read, you can update, you can delete, you can modify, right? All these functions are on your backend server, correct? So imagine that all these functions that you have, instead of it being on a server that you deploy on AWS or DigitalOcean or all the different providers, server backend providers, right? You're placing all these functions on the blockchain, right? And these functions are actually encapsulated inside this term called smart contract. And this smart contract contains all these different functions that you have defined, and that is your business logic, right? And the third thing is account data. So your account data is like your wallet address, right? Inside your wallet address, how much, let's say if you're on Ethereum, then how much Ether do you have in your wallet? But let's say if I'm in Solana, then how much SOL do I have in my wallet? And lastly is the state data. So a state data, it's different from your account data, whereby state data is more related to a smart contract. So for example, if today someone were to use a particular platform, a particular decentralized application, right? And this user this user is, using this platform, and this platform wants to track the user's usage. What would the platform would then, create their own custom variables that keep tracks of, okay, whenever a user, make a trade or do certain actions on my platform, increase this custom variable, this custom counter by 1. So these are your custom variables that are created by your smart contract developers to keep track of the states of things like the user, or it could be not just individual users, or it could be on a protocol level as well. All right, so that is your state data. All right, so back to the topic of transactions. So the total number of transactions since inception is, of course, it has been increasing throughout the years, but it has been increasing at different pace for different protocols. So for example, if you look at Tron protocol, we have it at over 4.8 billion transactions. Ethereum is at over 1.8 billion transactions. Binance Smart Chain is at over 3.9, whereas Solana is over 140 billion transactions. So you can see that there's actually a massive amount of data, and that also equates to many insights and also opportunities that we can, derive and utilize. So this session will focus more on Solana and the data inside Solana and how we can extract the data out of the Solana blockchain, and also and analyze them, and also see what we can, how we can utilize it. But back to Solana's history. So Solana is actually founded by someone called Anatoly. He actually published a white paper in November 2017, and he created this new sort of algorithm, deep proof algorithm, where it's called the proof of history. All right. So basically, proof of history, in simple terms, introduces a time aspect in its consensus algorithm, whereby, instead of, in Ethereum, there isn't really the time aspect. So nodes have to communicate with each other and agree that, certain transactions are in this particular sequence. So it's transaction 1 to 10 happens sequentially. So all the nodes must agree that, okay, it's ABC, not CAB or other sequence. Right. And this takes time. Confirming these sequences takes time. For Solana, our nodes are different because all the transactions has a timestamp which cannot be created with a fake sort of method. It has to be real because there is certain cryptographic algorithm involved. Okay, so with that, the transaction time actually improved because of our proof of history, and that's just one of the many reasons why the transaction speed per second on Solana is faster. Okay, so the code base was moved to Rust and became Project Loom. In 2018, Solana has a throughput of 10K transactions per second. March 2018, Project Loom was renamed to Solana. So previously, Project Loom was Solana was called Project Loom. And Project Loom, it is also a protocol previously, and hence there's a need to change name. And in July 2018, a testnet of 50 nodes was built, which managed up to 250,000 transactions per second. And in 2018, the throughput averaged about 200,000. Okay, so one interesting fun fact that you can, get out of today's session is that you can tell a friend that, okay, actually Solana is actually named after Solana Beach. And how did they come up with the name? It's because the co-founders actually served together a lot at Solana Beach when they worked for Qualcomm in San Diego. All right, so I'll talk a bit about the programming model. So for data analysis, right? Of course, you need those basic skills of, let's say if you use Python, or you use R, or you use like things like Scala. right? These are all like your basic programming languages that you have to master. So beyond that, right, so let's say you have already mastered Python, you know how to do data manipulation using libraries like pandas or numpys, and then you know how to use visualization with libraries like Seaborn, Matplotlib, or Plotly, right? This is not enough for us to further to analyze blockchain properly. So the first thing that we need to learn, right, is to understand how the transaction, how data looks like for each blockchain and what it actually means. And this is actually very important. And in fact, we wouldn't even be able to cover it in one day because it is so huge. So if you are really serious in analyzing data on Solana or on any other chains, right, it is very important to read their documentation. And for Solana, I recommend this documentation. You can access it at docs.solana.com/developers, right? And you can start from the start. But if you like to skip and go to the more important part, right, you can go to the programming model overview. So it's at this one over here. Sorry. It may have changed a little bit. Let me see. Oh well, it may have changed a little bit. Yeah, but I think the most important part is the core concepts part, where you need to understand what are your accounts, right? And then what are your transactions. So transactions are like an overview of it. It contains things like message, instructions, and your account. And within instructions, right, there are three things that's very crucial. It's your program ID, it's your accounts, and it's your instruction data. Okay, I won't dive deep today into what all these means because it's gonna take very long. Okay, but if you are really interested, please look at this. All right, and then there are transactions and also of course programs. But for data analysis, you don't really need to understand programs that much. You have to understand transactions more and also accounts, right? Because programs are your smart contract code, and you don't really have to sort of deal with smart contract code when you're let's say a data analyst for that does on-chain analysis. Okay, so now with that, all right, a very simple explanation of instruction and transactions, right? For Solana, right, the most basic operational unit on Solana is called an instruction. So you can think of an instruction as like a one function call to a program. For example, if I want to send one USDC from Ben to Mary, right? That is an instruction. Okay, and a transaction is a list of instructions. So there are certain limitations on Solana whereby there's a maximum number of instructions that you can put in a transaction, and it is about 1,232 bytes worth of instructions. Okay, so we can then the clients then update the runtime. So you may come across a lot of this term called runtime. So basically, runtime means the data stored on the Solana virtual machine. Okay, so for example, my account or Ben's or Mary's account, that is our runtime. So if you want to update the runtime, like for example, debiting an account. So in our case, in our example here, we want to debit Ben's account, and we want to credit Mary's account. This is updating runtime. We have to submit a transaction via the RPC API. Okay, so a transaction can look like this, whereby it's like a list and there are multiple instructions. And like what I've mentioned, there is a maximum number of instructions that you can fit into a transaction, and there is no minimum. So for example, a transaction can just contain one instruction. No problem with that. Okay, so how would a transaction with multiple instructions to look like, right? It's for example, if Ben wants to send one USDC from himself to Mary, and from himself to say Jane, and from himself to say Edward, right? 3 different people. So what he can do is actually he can put each instruction, send to Mary, send to Jane, send to Edward, right, into one transaction. And what will happen is that he only requires to send one transaction. And that means that he only need to pay one transaction fee, even though, transaction fee don't really matter on Solana because it costs like less than 1 cent. Okay, so one more thing to take note is for instructions, right? When instructions are placed inside a transaction like this, what this means is that instruction 1 will be processed first, followed by 2, followed by 3. So this will be processed in order based on how you put it in the list. Okay. So the next thing I want to cover is this thing called the remote procedure call. It enables one program to call a function or method in another program over a network. So it is quite different from, say, your usual REST API. Oh, so Kenneth asked, what other kind of instructions are there? Is it just from A to B? So no. So there can be very, very complicated instructions, right? For example, let's say I want to mint an NFT, right? Then that transaction is not purely sending one USDC from one account to another, from A to B, but minting an NFT requires, creating a token from, out of like sort of thin air, not really a thin air, but you have to create a token and then you have to place that token in someone's account. That is also considered an instruction. So an instruction is, it could be that, or another example of instruction is, I want to place my NFTs on a marketplace. That could be an instruction as well. Like I want to list my NFT for 20 SO on, say, for example, OpenSea or Magic Eden. That is also an instruction. Okay, so for RPC, it's different from your REST API, whereby for REST API, it's very common for you to sort of have this like this URL, where for each URL, for example, /user /1, and then if it's a post request, then perhaps you're modifying the user's account and things like that. You can sort of identify, or you can sort of state the URL of your API, right? And then you can do whatever you want. But for RPC, it's actually invented like earlier than your usual REST API. So what it does is that it has different functions that you would have to call yourself. All right, and there are a lot of things that are sort of considered different from your REST API compared to your RPC. However, the similarity is that you can use your HTTP to sort of request for your or call your RPC. All right, so client sends a JSON RPC request to the RPC node, which includes a method name and any parameters needed. The server then processes the request and returns a JSON RPC response, which includes the result of the method call or an error message if the method call failed. So for this RPC, we won't be really touching the RPC by itself because we'll be leveraging on an SDK today. So we don't need to handle all these RPC calls. But it is quite different from how you call a REST API. Yeah, so this is one thing that you would have to take note. So for today, we'll be tapping on Python SDK for Solana, which makes the JSON RPC API calls under the hood, and it can be installed with this command line over here. So one reason why we want to use the Python SDK instead of the RPC is because, or using HTTP requests to access the RPC API, is because it is a lot simpler to make one function call rather than having to list down all the requests and then typing out all the parameters and etc. required. That's one. And also it is also for faster prototyping. So one cons of using this SDK is that you are limited to what the SDK provides. So for example, if the Python SDK do not have access to certain JSON RPC API, then you wouldn't be able to access it using the SDK. You would have to directly tap on the JSON RPC API call. So let's take a look at this JSON. So you can see that all these Solana JSON RPC HTTP methods available. So for example, your get account info, right? You post this, and this is what you get in response, and your get balance, and all these different methods, right? These are all methods available to be called. And sometimes, the Python SDK won't provide all these methods. But yeah, if you want to check whether they have those methods, you can actually go to this website and check it out. So you can see that, okay, these are all the API client, and they are like your get account info, which we talked about just now. There's a get account info here as well. All right. And yeah, so for example, if I want to, let's say I want to access this method called get token accounts by owner, right? We are able to access it through the JSON RPC directly, right? But let's see if our SDK have or not. So we have to check, what's it called? Get token accounts by owner. So let's go and check get token accounts by owner. So yeah, here you go. We actually have it. Yeah, so this is, yeah, so I would say that this particular library for the Solana SDK is quite comprehensive. All right. So to the topic of decentralized exchanges, there are generally two main types of decentralized exchanges today. So the first type is called the central limit order book, and the second type is called the automated market maker. So the exchange mechanism behind each type is different, but essentially they facilitate the exchange of token pair. So like for example, let's say even for centralized exchange or any exchange for a matter, if you want to swap like one ETH for one BTC, right? That is the role of an exchange. It allows you to give up a certain amount of asset. So in our case here, I want to swap 10 ETH for one Bitcoin, right? The exchange will accept 10 ETH and then it'll give you one Bitcoin. And of course, every exchange would have different rates. And of course, every exchange would have different exchange mechanisms. So for example, for a centralized exchange, I would assume that they would have a order book, right? That's being run on their backend server, purely Web2 solution, right? Whereas for example, if we are talking about a central limit order book on a decentralized exchange, they would also have an order book, but all of this information would be on chain. All right. So let's talk about CLOB, which is your central limit order book. So orders are first ranked according to their price. Then orders of the same price are then ranked depending on when they were entered. So you can see that this is how a typical order book would look like, right? Where the buy image, right? So for example, buyers who want to buy, right, they would put a buy bid. So when they put a buy bid, right, when we see this 80 here, right, it means that there are buyers who are willing to buy this particular asset for $99.99 and 80 lots. There's a demand for 80 lots for this. Whereas on the red side, you can see these are your sell orders or your sell offers, right? And your sell offers are your people who wants to sell. So you can see that at this block, there are people who wants to sell, who are willing to sell at $100, right? And the demand, the selling demand or the selling supply for that is at 175 lots. All right, and you can see that to calculate the spread, well, it's just the best offer minus the best bid, which is about 1 cent, right? So in our example over here, if a seller would place a sell limit at $99 and he wants to sell it for 100 lots, okay? So what would happen is that, okay, you can see that the seller has already crossed the path of the sort of the lowest best offer, right? He has crossed the path. So actually his orders would be instantaneously filled. So what would happen is that the order book, right, there is this mechanism where they will check, okay, so currently what's the highest best bid? And it is at $99.99. And $99.99 is more than what the seller is willing to take, right? So these 80 lots will be filled first, right? So the seller would receive $99.99 times 80, and then the next best bid price is at $99.98. All right, and then 20 will be filled up because 80 plus 20 is 100. So this is what the seller would get. So you notice that there's 175 lots over here, right? What will happen to 155 of them? They will just stay there. So how do you choose the 20 out of the 175 if they are from different buyers? We chose it by when they were entered, right? So the order of the same price, they rank by price first and then rank by time entered. Okay, so this is your central limit order book. Then comes AMM, and it's first introduced in 2017 by Uniswap protocol. And AMMs were introduced to provide DEX an efficient and user-friendly way to trade assets, especially in low liquid markets where traditional order book-based system is less effective. So the benefits of AMMs over CLOBs are it has continuous liquidity even in low volume markets. It is considered simpler to use than CLOB because for CLOBs you need to put your sell limit, or you need to put your buy limit and things like that, which you don't have to do for AMMs. You just take the price. All right, and the last point is trades executed instantly without order matching. So how does AMM actually really work, right? Many AMMs use a simple X times Y equals to K constant equation. So given ETH USDT liquidity pool as a case study, so for AMMs, most of the case, it is usually a pair trading pool, whereby in our case here is Ethereum and USDT. Okay. So when ETH is purchased by traders, they add USDT to the pool and remove ETH from it. All right, so you can see that the curve is here. All right, so how do we calculate the price on AMM? Because like price is instantly settled on AMM. It's an instant swap. All right, so for example, if at the start our Ethereum / USDT pool has 100,000 USDT and 100 ETH, right? Then our constant, right? It's so you can imagine that this is X, this is Y. Then our constant would be 10 million when you multiply them together. So that gives us 10 million. That gives us K, which is 10 million. So given that a user wants to exchange USDT for 1 ETH, this means that there will be 99 ETH left after the exchange. So we then calculate how many USDT will be needed in the pool to maintain our constant K. So our constant K, you can remember, it is 10 million, right? So how do we maintain a K of 10 million when our ETH is 99? So very simple, we just take 10 million divide by 99, and we get this amount, $101,010.101, right? So this is the USDT that's required when if ETH is 99 in our pool. This is the USDT required to make the constant maintain at 10 million. So since this is the number that's required, right? What we do is we take this number that's required minus the original amount, which is 100,000 of USDT, and that gives us $1,010 and 101 cents of USDT to take out 1 ETH. So the user has to pay this amount to take out 1 ETH. All right, so this is how the most simple AMM work. So in this session, we will look into transactions related to Radium. one of the largest AMM decentralized exchange on Solana. So if you are curious about Radium, let's type Radium, right? You can see that this is Radium. It allows you to swap. You can see liquidity over here. Let's see. Let's go to trading. Let's not go to trading. Let's look at the pools, right? You can see that these are the different pools. Like for example, like what I mentioned, there are mostly pairs. So these are your Radium token and Sol pair, and there are multiple pairs that's governed by Radium. Yeah, so this is how Radium looks like. So for example, if you want to swap, you can just simply swap like that, right? Like for example, if I want to swap all my Sol to Radium token, then this is how it look like. So I'll receive 310 Radium in exchange for 3.91 Sol. Okay, so for this part of our session, you are required to install Anaconda or Jupyter Notebook, and you can follow along. All right, so just open up this link, and then you can just simply download this. So I would assume that you are already familiar with opening a Jupyter Notebook, so I won't be going through that. Okay, so once you open a Jupyter Notebook, you'll hit this page over here. Okay, so this page would be the main content of what we'll be going through for our hands-on session for blockchain analytics. Okay, so have a read over here. Just basically talking about what, by completing this tutorial, you'll be able to have a good understanding of how AMM works on Solana. You'll also be able to learn about the token swap transactions, and also, of course, become a Python magician and a visualization wizard. So you learn how to start from downloading data or reading data from a Solana endpoint to detecting suspicious transactions, and you'll be guided step by step. All right. So just a very brief explanation of how Radium works, like what I've mentioned just now, how AMM swap works. All right, so just market makers are essentially liquidity providers, right? Liquidity is a measurement of how fast and easy an asset can be bought or sold. So if you find that difficult to understand, just replace the word liquidity with money. So like liquidity provider is actually money provider. No liquidity is actually translates to no money, and boost liquidity translates to you need more money. So even though they can be different, they can also substitute for each other in many contexts. So Radium uses several liquidity pools since the start. Radium now uses liquidity pool V4 for token swap. So you don't have to know all these actually. All right. So the most important part is when a user swap tokens on Radium, right? The original tokens are actually deposited into the liquidity pool, and the counter token is withdrawn from the liquidity pool. And of course, the price is being derived through the equation that I've mentioned just now. Okay. So the AMM automatically fixes the exchange rate, and it's calculated based on number of tokens, and it's always measured in pairs, like what I've mentioned. So several types of transactions happen around AMM, and this includes, but it's not limited to, token swap, liquidity deposit, and also yield distribution. We won't be talking about two of them. We will only be talking about token swap today. So a successful transaction usually involves a token swap between multiple accounts. In Solana, even the same user tokens are kept in different accounts. So for example, let's see this particular swap over here. It may look a bit complicated, but it's actually very simple. I don't think it's very clear. Okay, I don't think it's that clear. But you can see that, okay, the sender, right? The sender is here. The sender is also depicted here towards the end. And you can see that, okay, let's trace this, right? The sender sends this amount of Atlas token to Radium, which is our AMM, right? And then in exchange, Radium sends 33 USDC to our user, which is the sender, right? So with the 33 USDC, right, you can see that this user actually sent 33.4255 USDC, which is exactly what the user has received from Radium, back to Radium, okay? And it then received 33.4 USDT. So basically what this means is that even though it's 2 steps, right, whereby it sends the user sends Radium amount of Atlas coin, and then Radium sends USDC to user, then user send USDC back to Radium, then Radium send to USDT. But the outcome is actually there is a token swap between Atlas token and USDT, not USDC. USDC is just the sort of a transitionary sort of phase. All right, so this is how a swap would look like. And of course, you can, if a user would want to swap to USDC, then it would just be like one line, right? It will be so much simpler. So Timothy asked, is this counted as 2 transactions or 1? So this is most likely counted as 1 transaction, but 2 instructions. So the first instruction is user send Atlas token to Radium, Radium's sent to USDC. So this is an exchange. So that is 1 instruction. All right. Then the second instruction is USDC to USDT. That's another instruction. But this is bundled into 1 transaction. Yeah. So the outcome for this transaction is decrease in Atlas for the user, but increase in USDT. Okay. So if you want to follow along this tutorial, we are welcome. You can use any Solana node endpoint for this tutorial, but some endpoints may give you errors for rate restriction. So the Senko code is developed and tested with RockX, our official sponsor. So these are one of the many reasons why we chose RockX. So they do not have no limits on the request rate per second, which is very useful because we'll be sort of like spamming the endpoint with trying to get as many transactions as possible. So that's first thing. Second thing is it's free. So you have up to 100K requests per day. And the last thing is it has a very quick node deployment. All right, so how do you get started? You just go to this website over here. All right, and then you just sign in. Depending on what account, you can just sign in into your Google. So let me try and sign in. Okay, so I'm signed in, right? And then you depending on what chain you like. So for our case, I click on Solana, right? So let's say if I want something else today, I can just go Ethereum, and then like I can just click on the free one and then kind of pay with balance. I don't have to pay, it's free, $0. So the same thing I did with Solana, pay, and then I would have an API. Then in order to access the API, right, you need to click view API, which I won't be clicking, right? So this is to prevent sort of abuse, right? So you click on the view API button, okay, you get to this page over here, all right? And you get to see what's your usage. And of course, there's 100K quota per 24 hours. So I've already used up 70,000. All right, and how do you view your API key? Right, you can, there's this, when you scroll towards the end, there's this thing called API access. You can click create API key, and then you can view the key. All right, so once you view the key, you just copy the API key, and you can paste it over here, this string over here. Once you're done, then you're good to go for the endpoint. So the next thing that's required is, of course, the Solana SDK that I mentioned just now. And this can be installed running either pip3 or pip. So it depends on sort of what configuration you're on. So if this doesn't work, I recommend using pip instead of pip3. Okay, run this code block, and then you run this code block as well if you do not have plotly. All right. Okay, so on this particular code block, we are doing many things, which is very important because this code block is responsible for importing the libraries that we require and also define Explorer-based URL. Okay, so firstly, we import JSON because it comes in, the responses comes in the form of JSON. And also import Solana because we want to access the Solana library. And time, logging, threading, it's all of these are more for purpose that to sort of speed up this entire process, especially with multi-threading. NumPy is for your data manipulation. This is for your requests. So we'll be using request, more specifically a GET request, because we'll be sort of accessing a particular website to obtain the token names later. Okay, and okay, there's 2 JSON, so you don't need 2 JSON. And actually, all right, let's just leave it here. Okay, we need a client because we are connecting to the client like this with the API key that you provide just previously. Okay, and then this is your Explorer URL address that is your prefix, right? Which you add maybe your address here and here as well later on. Okay, so these addresses are very important. This is your Radium AMM. So Radium AMM it's basically the smart contract, right? The ID of the smart contract Radium users. And this is very important because we want to find out the transactions that's related to this particular smart contract in order for us to analyze all the transactions of these AMM swaps happening. Okay, then of course, there's the liquidity pool. So what's this liquidity pool? It's just like you can just think of it as like a vault or like a bank, where Radium has one bank, right? And this bank contains all the tokens of the different liquidity of the different pairs. All these different pairs are stored in just one bank, right? And this is stored in this address. And of course, this SoScan address. This is just the prefix, all right? So the first step we want to do is to download Radium data from Solana. And how do we do it? We first define these variables. All right, so this last signature is just going to be the variable that helps us track what is the last signature that we have read so far. And this is very useful because we'll be doing it batch by batch, 200 transactions every time. So we need to know, like, for the last 200 transaction, what's that signature, so that we start from that particular signature onwards. And the result array is basically the array that that's going to contain all your transactions, all your valid transactions. And this is your rounds, keeping track of how many rounds we have, read the transactions already. This is your transaction count, and this is your max transaction count. So this is like 20,000. So we are only reading 20,000 transactions today. Okay, so when you run this is a function that checks for valid transaction, and it appends into result array. All right, and you can see that. Let's take a look at how a transaction looks like. Okay, so let's take a look at how a transaction looks like. So let's do HTTP client, the transaction, and let's do signature here. Oh no. Oh, of course, you need to put this. All right, you can see that when, let's say when we retrieve a transaction, right? This is what you will see, what you return, what you receive. And basically, this is your signature, your transaction signature. So let's say if you want to look at Explorer, right? So let's go to solana.fm, right? And we can paste the signature every transaction has a signature, and you can treat the signature as like an identifier for each transaction. So it's like a unique identifier. Okay, and you can see that this is what's happening in the transaction, and it's actually a lot of things going on, right? So the most important thing is that the account inputs. So towards the end of the transaction, right? What are the changes? So for example, for our address, this particular address, the number was so decreased, and what else? Basically, this number also decreased. And why is that so? You may ask, and this because this transaction errored. So for an error transaction, right? What will happen is that the transaction fee would get deducted, but nothing else would happen. Right? You can see that there are a lot of error transaction related to an AMM because there are a lot of people trying to do arbitrage sort of transactions where they try to like buy from one pool and then sell to another pool. And most of the time, because of the volatility of each AMMs, then there may be like some price variations that they are trying to get, and they are at the end of the day they are unable to get, which fails because of how volatile AMM is. Right, this is your signature, and of course, these are your messages. Your account keys are like what are the accounts that are involved with this particular transaction. All right, and okay, so I want to show what's the more important thing, which is your pre-balances and post-balances, right? Pre-balances, post-balances basically tells you how much SOL there is left. This is before, how many SOLs there are, and before and after, how many SOLs after the transaction that there is. That's one that is quite important. The second thing that is very important is the pre-token balances and the post-token balances. Right, so post and pre-token balances basically tells you, right, for that particular transaction, how much transaction did a particular address lose for that particular transaction. So for example, right, let's see, this is so huge. Let's go down and see how a successful one looks like. So let's go here. Okay, so for a successful one, let's look at their signature, and let's go to Solana FM and look at it. Okay, you can see that for successful one, apart from the SOL change, there are actually token changes. You can see that, okay, USDC here changed, right? For this particular address, they increased the USDC. And then the number of police token actually decreased. And yeah, and let's say if you like to see how it looks like on a transaction flow, you can see that, oh, this is what happened in this particular transaction. So it can actually get very, very complicated because, some people would pack multiple instructions into one transaction. And this is what you would get. All right, so the most important part is, of course, the changes, the token changes, which is actually being reflected over here. So the token changes for the pre and post token changes, you see over here, pre-token balances and post-token balances in the next one. The next one here, this is post-token balances. And how do you get the change is of course taking the post-token balances minus off the pre-token balances to check the change in the particular token that you're interested in. Okay, so that's transaction and how it looks like. So you can see that what we're trying to do over here is to make sure that if you're familiar with Python, is to basically make sure that, okay, for transaction detail.value, we need to make sure that it exists first. All right, if it doesn't exist, then we will skip this entire if statement over here. And then subsequently, we check whether transaction exists inside the value. and we check whether meta exists inside transaction, and then we check whether post-token balances exist inside meta, pre-token balances exist inside meta. All right, and then we need to make sure that the pre-token balances is not equal to post-token balances, because we are not interested in these transactions, right? We are not interested in transaction that did not successfully do a swap, right? If the pre-token balances and post-token balances is equal, it means that there's no change, means that most likely it's a failed swap, and we are not interested in this. And hence we are filtering them out, and we append those valid one into our list. All right. Then we'll look into the last max transaction count, which is the last 20,000 transactions related to Radian AMM address. All right, so this is what we are trying to do. We are doing a while loop, right? And this while loop only stops when we have already processed 20,000 transactions. Okay, and basically what this does is it retrieve all the transactions that's related to our Radium AMM, and only 200. Okay, and then we will just keep doing this 200 batch by batch until we get 20,000, and hence you can see that we have about 100 rounds, right? Because 100 times 200 is 20,000, and we define 20,000 over here. So it's going to take about 10-15 minutes to complete this run. Yeah, so I've already run this. I'm not going to run it here now, but if you like, you can run it on your own. All right, the next thing we would do is we would then process the result and store it in this processed transaction array or your list. So what do we mean by process transaction? Process the result, right? Basically, we just extract out the signature, right? So now I mentioned signature is like your unique identifier for each transaction. And we also extract out the sender. So what's a sender? A sender is someone who initiated a swap. So for example, today I want to go to Radium and I want to swap one Bitcoin for 10 Ethereum. I am the sender because I initiate the swap. All right, so this is the sender. We want to find out who initiates it. All right, so you notice that it's 0 here and 0 here. All right. Usually there will only be one signature for a transaction. So that's why it's the first item in the list. For account keys, right, there's this account keys over here, and it is actually a list of addresses. And we are only interested in the first one because the first one is the one that actually initiates the transaction. Block time, of course, to see what time was the transaction being executed, and the slot as well. I won't explain what the slot is. All right. The more important part is the post-token balances, pre-token balances, like I mentioned just now. We want to keep track of the changes in token balances. So how do we do that, right? We first create a list, an empty list, right? And then we zip it up. We zip the pre and the post-token balance up to pre and post, right? And we do a statement over here, right, where we calculate the change is equals to the post amount minus the pre amount. All right, so if you're curious what this UI token amount means, it basically means like it translates to user interface token amount. Yeah, so just use that. This requires some context knowledge to figure out. All right, and then the owner, right? We want to find out who is the owner, the initial owner of the particular token, right? So the initial owner will be the pre, and then token we also use pre mint. Okay, so if the change is not equals to 0, meaning that there's indeed a change in the amount of token, right, after the transaction, we then append it into our token balances, which is the list. If there is no change, then of course we just ignore the particular pre and post token balances. All right, and then the result would just simply be transaction signature, sender, block time, slot, and then token balances would be your list. All right, and then you process transaction array. So you can take a look at how it looks like this. All right, so for this particular transaction, give me a second. Right, sorry. Okay, so yeah, for the first particular transaction, you can see that okay, the signature of this is 3BR, I believe, which is what we have searched for. All right, and who initiated it? It is this address 6CS. So you look at this, right? You can look at the account 6CS, right? Is the one that initiated it over here. Even though there are multiple sort of instructions being packed into one. All right, so this is 6CS. Okay, and then the block time, the slot, and you can see there's this token balances where there's a change. The owners, the pub key, you can see that, okay, let's take a look. ESDC coin. The change is 0.02829. And let's see whether it's accurate, right? So let's go to the account inputs over here. And it's USDC, it's 0.002829, which is exactly what we have got here, right? So you can see that we can obtain certain information, not just through Explorer, where almost all protocols have their own sort of version of Explorer, but we can also use it, we can also derive the changes purely through code, through Python querying of the RPC API. Okay, with all this information available, what we have basically done was, instead of having this full list of pre and post token balances, right, we've basically filtered to those that, you know, when only those that has changes. So chain police token, USDC token, Radium token, Repsol tokens. Yeah, only these would be, you know, being left or being kept. Okay, so the next part we want to do is to map the token's address to readable token names. So because right now, right, it's now you can see that the token name it's not exactly readable. What we want to do is we want to make it readable. So at the start, right, at the start, the token name actually, we actually do not have the token name. So this actually only occurred because all these actually only have the name, the token name over here, right? It's because of this step over here. We ran it beforehand, right? But without the token, right, it will look, our token will just look like, oh shit. Oh no, it's hang. Give me a minute. Yeah, I think the array was a bit too large, and when I run it, you would you know, cause some error or some problem. So I don't think you should actually run the entire array. It's very huge. So what I wanted to show is actually just one such array. And at the initial stage, if you follow through the notebook, right, the token is actually to the token address, not the name. So we want something that is, you know, easy to identify and to analyze, and hence we want to replace the token with human readable name. Oh. Okay. So yeah, so we want to convert like such addresses, right, to like a name like USD coin or Star Atlas DAO coin, things like that. How do we do it? We basically sorry, bear with me. Yeah, so basically what we are doing here, right? It's we are doing a request that I've mentioned just now. And how does it look? So let's just check it out, right? So how does this actually look over here? So let's try it. So this looks like this. So when you go to scan, right, you can see that oh no, now it doesn't work, but let's look at the latest request. Okay, and then let's look at the latest data. All right, and you can see that these are actually information that we have gotten through a GET request to the scan website. And the string, the token here is actually the address. So if I were to do it again, it wouldn't work anymore. All right, and this actually returns a JSON. And the JSON, within the JSON actually contains information like the name, right? So our name here is block asset, right, which is pretty cool. And hence we are able to convert like the very sort of non-human readable name like this, the mint, to the coin name instead. So this is what we are doing over here. So basically for every unique coin, we will be querying SoScan's website, and SoScan will return us the token's name, and then we will just store the token's name somewhere. All right, and through this, we are able to obtain all these token names, right? Block asset being the last. Okay, so now that we have the token name, we are then able to analyze our data better. So the next thing we want to do is, of course, to sort of make it even more proper or no need for our arrays. So what I'm doing is I am actually sort of modifying it into a dictionary of this format, right? Where there's a transaction signature, a sender, a block time, the slot, and then of course the token change, owner token change, and etc. So why do I want to do that? So when we look at, for example, process transaction array, right? You can see that right now the token balances for each transaction, right? There are multiple token balances. Okay, and we want to sort of flatten these token balances, right? It's a list of dictionaries. Okay, and how do we flatten it? We run this algorithm over here. Okay, and thereafter you look something like this, right? Where it only contains one particular sort of token change. So this is how we flatten it. So you can see that, for example, let's look at token balances for our first one. The length of it is 10, right? So there are actually 10 tokens, 10 token balances change. So you can see that, okay, our signature for this is 3BR, right? So you can see that it would go all the way until the 9th one because it starts from 0, and it's still the same transaction because we have the same signature. But if we go to the 10th one, it will be a different signature already. Okay, so basically what I'm trying to say is that we are flattening the token balances. All right. Okay, so for summary, right, we have read 20,000 transactions, right? And at the start, we filtered these transactions into valid transactions whereby there are actually token changes. And how many valid transactions are there? There are only 514 valid transactions out of 20,000. All right. So you realize that out of 50 or 40 out of 40 transactions being made to Radium, only one succeed. And this shows that actually the arbitrage market over here is actually very competitive, and it also means that it is a pretty efficient market since there's a lot of sort of arbitrage bot trying to earn money here and there. All right, so the most transacted token top 20. So if we were to run this, oh, why do I not see anything? So let me see. Let's see. All right, transaction DF is here. Temp DF. Okay. Let me refresh. Okay, so let's go down. Oh, okay, so it's odd. Somehow the figure is not showing, which can be pretty odd. Okay, I think there must be some sort of problem with the kernel over here. So what I'm gonna do is I'm just gonna quickly save the data. Let's see. Okay, TXDF. Okay, so I'm just gonna take TXDF over here. Right? And then what I'm gonna do is just gonna so I'm just gonna write it into a CSV, and then we'll see how it goes. And then probably restart the kernel. And yeah. Do I need anything else? Yeah, so the only issue of me rerunning the entire notebook now is that we have to, read and query the blockchain again. It's gonna take like more than 15 minutes, right? Which I'm trying to avoid. So let's see if this works. So let's comment this out. So but on your side, you don't have to do all this. You just have to run it once. And yeah, I think that could work. Okay, so let's try it. What do I need? What else do I need? Okay, so I'll restart the kernel, and then I will refresh it, and then I will clear all the out. Should I just clear? Yeah, I'll just clear all the outputs. Okay, and then I'll just reload this notebook. See if it works. Oh, it's lagging so badly. Oh. Okay, so I hope that it's not gonna lag anymore. Okay, let's try this. I'm still lagging. So meanwhile, I hope that you guys are able to create your ROCX credentials and run all the code in the notebook. If you have any problem, just feel free to ping me or just ping the chat. Okay, let's run this. All right, I need to first define address liquidity pool. So let's go ahead and run this code over here. Then let's go all the way down, run this. Yes, so you can see that, right, we are able to obtain the top 20 token transactions through our data that we have stored. All right, and we are able to analyze that. Okay, 28.6% of the token transactions are related to USDC, and then there's this thing called slow protocol, marinate so, and so on and so forth. Right, that is number of token transaction. It's nothing got to do with volume. It's just transactions counts, right? So the next thing we want to find out is transaction volume of the top 5 tokens. So what do I mean? It's we take the top 5 tokens and we find out what are their transaction volume. So when we talk about volume here, right, it is the amount of token being involved. So for example, if let's say one transaction there is 20 USDC being swapped, right, then we'll consider the amount 20 instead of just one transaction. So you can see that it is different from our graph at the top where it just purely counts transactions, right? There's terabyte, which is having a count of 62, right? Actually is second in terms of volume, right? So you can say that even though terabyte has lower volume as compared to like slow protocol, but the amount per transaction that terabyte is being transacted in is larger. But of course, USDC is the king over here with the highest number of transactions volume for our AMM. All right, so now we know that USDC has the highest volume and also has the highest number of transactions count. Now we want to find out about the users. So basically this code block over here, right, finds out who are the top 20 users or senders. And how do we calculate the top 20 users? It's by finding out how many token exchange count they have made, right? So you can see that, when we run this code block, oh no, we are not able to do this because we did not save process transaction array. So yeah, I think this may be a bit of a problem to run this, but please run this on your own. So basically what this does is that, it calculates the top 20 center, based on the number of transactions, and we basically put them in a very nice graph in a bar chart, and you can see that the top transaction, you can try and find out belongs to which address, and most likely this particular address is not like an individual, but it's like perhaps a particular protocol that interacts very frequently with AMMs. Okay, so we can list top senders transactions over here. So let's try it. We run this. Oh, it's not defined. All right, I think I have to define the one at the previous one. Yeah, so this one as well, if you run this block, it will obtain who is the user that interact the most with the AMM, and what for that particular user, what is each transaction, what's the user trying to do. So you are able to sort of investigate, okay, what's this user trying to do. All right, and the last part is it's just a very sort of fun exercise where we try to identify a sandwich attack, right? So basically, a sandwich attack is sort of someone that's trying to front run a user who's trying to do a swap. So for example, you can imagine that like for example, Sally today, right? Sally wants to do a swap for USDC in exchange for SOL, right? And someone, maybe some person, who has faster connection to the validator or something like that, will be able to see Sally trying to do that, right? Trying to swap USDC for SOL. And what the person does, right, is that, okay, the person would first buy the USDC SOL, right? He would first buy it, they call it front running it, right? Where the person buy the pair, and then when Sally decides to buy it later, like right after, the person sells it back to Sally at a profit. So this is called a sandwich attack, right? Where you make use of someone's intention to buy large volume of like a particular asset in a AMM pool. You front run them, and you buy before they buy, and then when they buy, you sell it back at a higher price, and then you make a profit. That's a sandwich attack. All right, and this algorithm basically identify potential sandwich attack, right? I won't like go deep into explaining what each line does, but basically we are able to identify two different transactions, right? One transaction being the front running one, which is to buy the pair before someone else buy, and then the second transaction is selling the pair to that particular person. Right, so we are able to identify these two transactions, and then whatever in between would be your potential target. All right, and then then this is the end of the Jupyter notebook. All right, so you can see that actually if you're familiar with Python, you can do a lot in terms of data. Reading data from Solana, and then making all the useful insights and producing all the useful insights here. And possibly you can come out even with solutions like a web app or whatsoever that monitors transaction flows, or monitors sort of weird behavior or malicious behavior or intent. And all these are possible using analytics. All right, so this is the power of using Python to analyze data on Solana, which is something that you cannot do, you purely using Explorer. It's going to be too hard to, manually check all these. And especially if you want to analyze someone trying to do a sandwich attack, it's going to be so difficult as compared to using a programming language and querying via RPC API. So this comes to an end to my notebook example. If you are interested, please download the notebook over here, make the necessary installations, and also go and get a ROCX endpoint. All right, so it's come to an end to my session. If you'd like to learn more about Web3, it could be smart contract development, it could be analytics, or it could just be your general blockchain knowledge. Please join Metacamp's Telegram group. All right, we are a very inclusive and very supportive community. We regularly post knowledge, regularly post events as well, articles as well. So yeah, it's free to join, so why not just join, right? So this is our community Telegram link. And lastly, just another shout out to our hackathon. It just started yesterday, but we are still accepting registrations. It's a global hackathon that we are running actually in Singapore. So this hackathon runs globally, but we have sort of like a Singapore chapter. And we are organizing workshops throughout this period. And also, if you register for this particular hackathon, you are entitled to, come down to our training center. You can make use of our co-working space, and also, you can hang out and brainstorm hack ideas together with your team over there. Yeah, so comes to an end of my presentation. So thanks for your attention.
Okay, thank you very much, Vincent. And okay, we also send the record of this video to our YouTube NTUOSS YouTube page. And if you have any question for our speaker today, please don't feel shy, and you can just open your mic or just type in the chat box. Okay, if no question, then there will be the end of today's workshop. Do remember that we have another workshop next week, and the topic will be on Rust and I think the smart contract development, right, Vincent?
Yeah, that's right.
Okay. And if not, thanks everyone for joining to this workshop. Okay, you can see you next week.
All right, thanks everyone.
Okay, bye.